afternoon, everyone. So for today, we'll be looking at the application of linear differential equation. And from there, we'll move on to other system of equation. Can you hear me now?
Yes, sir. That's it.
Okay, thank you. Can you see my screen?
Yes, sir.
Oh, okay, thank you. So let's try and tell others on the platform that the class have started, and they should join us on time. So the last week we discussed this, and I believe all of us we're on the same page with this. But today we'll be looking at the application. How do we use differential equation, linear differential equation to solve real life problems? So that's what we'll be looking at now. So I want us to write this following question down. Application of linear differential equation. Application of linear differential equation. Under it, we have mathematical modeling, whereby we use mathematical modeling to solve some of the problem. And how do we get to the mathematical modeling? We use those models, this of linear differential equation. So let's look at the application to Newton laws of cooling. Newton's law of cooling. So for Newton laws of cooling, there are things we need to know. Number one things we need to know is the Newton law of cooling states that the Newton laws of cooling states that the time the time rates of change of the temperature of temperature of body of a body is proportional to the time to the temperature difference between the body and its surrounding medium. And the surrounding medium. So we have using the Newton law, using the Newton's law of cooling, derive a differential equation for the cooling of of a hot body surrounded by a cool medium. So what this law is talking about is just talking about how how do you cool the cool medium means they're talking about the environment, they're talking about the space whereby when you a body in this case is not naturally to be human. It can be anything, it can be body or something, it can be any object. But now when we're now talking about the cooling system, how does the cooling system appear or occur through day-to-day activities and some areas whereby we apply them. But let's look at the ways we represent it in this case. Now, in this case, we said let's T denote. Let's T denote the temperature of the body. Let T denote the temperature of the body. And let Tm denote the temperature of the surrounding, of the surrounding medium. Then the time rate, the time rate of change of the temperature of the body is the capital T over the T. Remember, we are looking at differentiation is all about the rate of time. It changes, and Newton's law of cooling can be formulated as the capital T dt equals to minus K over T minus Tm. Tm is, we're talking about Tm as medium. I can open these brackets. I can write this one by saying it implies that the T or small t is equals to minus KT, don't forget, plus T, plus what? KTM. So I can put this one in this space. I said capital T over small t. When this move to the inside, it will become so capital KT equals to KTM. I can call this one equation 1. Where my K is positive constant, where K is a positive constant of proportionality. Since K is choosing positive, the minus sign in Newton's law is required to make the capital T, the T negative for the cooling process. So we need to take note that T is greater than Tm. That is, you need to know that the capital T is greater than Tm. So that's why we say T minus Tm. which imply that T minus Tm. So I'm just using this to lay a foundation. Now let's look at the example of such problem. Let's, for example, number one, example one says a metal bar at a temperature of 100 degrees Fahrenheit is placed in a room at a constant temperature of 0 degree Fahrenheit, if after 20 minutes the temperature of the bar is 50 degrees Fahrenheit, find an expression for the temperature of the bar at any time. Any question? Are we there? Hello, guys.
Hello, sir. Hello, sir.
Can you hear me?
I can hear you, sir.
I hear you, sir.
Okay, let's solve the problem. Solution now. The surrounding medium in the room, which is being held at the constant temperature, right? We know is started from 0 degree Fahrenheit, that is, we said the surrounding medium is the room temperature is the room which is being held at a constant temperature of 0 degree Fahrenheit so our Tm is equal to 0 in this case. And don't forget, we have the equation that says the T over the small t equals to minus K into T minus Tm. And it becomes dt over dt. When you open the bracket, you have plus kt, which is equals to 0. Since our Tm is equals to 0, don't forget. Am I communicating now? So all we need to do now is, how do we resolve this matter? We can now say that the capital T dt equals to minus kt, separable variable. So if you want to do separable variable, let's see, I can multiply both sides by, let all the capital T come to T. Let all the T goes to the other side. So I'll multiply the T, the small t, over capital T to both sides. I taught you how to do this. So it's still the same. So this goes with this, and this T cancel this. So we now we're left with the capital T dt equals to minus k dt. So integrate both sides. What do you have? When you integrate both sides, you have it to be integral of 1 all over t dt equals to minus k integral of the t. So if you integrate this one, what do you have? You have lim. You have lim t equals to minus k t plus c. Remember, the only thing that can cancel lim is exponential. Take exponential of both sides. So when you take exponential of both sides, what do we have? So we have t equals to exponential minus kt dot exponential c, which is equals to exponential t is c, c exponential minus kt. But don't forget that they gave us something in the question. Let's go back to the question. The question says, when your t is 100, what happened? Look at the question. It said, the metal bar at the temperature of 100 is placed in a room. Meaning at that point, our capital T, which is, remember from the proof here, they said, let T denote the temperature of the body. The body here, we are talking about metal bar. So the temperature there is 100 degrees Fahrenheit. So we substitute 100 into where we see T. At T equals to, at small t, the time is equals to 0. So capital T equals to 100 at small t equals to 0. So we put it there, 100 equals to c exponential minus k of 0. So we have 100 equals to what? Equals to c. Because exponential 0 will be, exponential 0 is 1. So, which is multiplied by 1. So you have c to be equals to 100. Now that we have c equals to 100, we can rewrite our equation by saying t is equals to 100 exponential minus kt. We can call this one equation 2. Right. We can call this one equation 2. Sorry, guys. Okay, so 100, we have this equation 2. Then remember, we are given the time. Let's go back to the question. The question says, if after 20 minutes, the temperature of the bar is 50 Fahrenheit, if after 20 minutes. So you can see what we are saying now. You can see the changes that is occurring. Okay, let's look at it. At T equals to 20. And don't forget, and our T equals to 50. So what do we have? So we are going to have it to be your equation 2. Equation 2 becomes 50 equals to 100 exponential minus k of 20. So, which is the same thing as 50 equals to 100 exponential minus 20k. So divide both sides by 100. When you divide both sides by 100, what do you have? You have here 1/2 equals to exponential minus 20k. So we are looking for that k. For us to get the k, we need to take the ln of both sides in order to cancel exponential. So we take the ln of both sides equals to ln exponential minus 20k. At the end of the day, we are going to have ln 0.5 equals to, this will be minus 20k. Then, how do we get the k? We can divide both sides by minus 20. When you divide both sides by minus 20, what do you have? You have minus ln 0.5 over 20 equals to k. If you do it very well, your k will be equals to 0.035. So it simply means that the expression we are asked to find, we can solve it by saying the temperature of the bar at any given time t is then t equals to 100 exponential minus 0.0. You remember we calculated the k, 5 t. So we call this one equation 3. Because that was exactly what the question asked us to do in that case. So find the expression. The question says find expression of the temperature at the bar at any time. So the temperature at any given time is equation 3, because the question can come in this form to ask you to find the expression of this particular problem. So, but the next thing we need to do, let's look at the question again. In case you are given a time, peradventure you are saying, let's say let's call this one Roman figure 2. Let's call this one B. And I call this one A, the first one. Let me call this one A. And I call this one B. Now for the B question says, find the time it will take for the bar in the equation 3 to reach a temperature of 25 degrees Fahrenheit. So remember, we're given 25 degrees Fahrenheit. So don't forget, the solution on this one is just said from equation 3. Remember, we have T equals to 100 exponential 0.035 T. And don't forget, we now said T equals to 25. What happened? Substitute your 25 here equals to 100 exponential 0.035 T. When you divide both sides by 100, what do you have? You have 25 divided by 100 equals to 100 exponential minus 0.035 T over 100. So what do we have here? We have 1 over 4. So from then, what can we deduct? How do we solve this one? Anybody, what's the final answer, please?
1 over 4.
Yes, 1 over 4. Yes, continue. What is your small t? Calculate it. You have 1 over 4 equals to exponential 0 minus 0.035 T. Remember, you take the ln of both sides, ln 1 all over 4, which is equals to ln exponential minus 0.035 T. So what do we have? This one we have ln 1.1 over 4 equals to, this we cancel, you have minus 0.035 T. If you solve this one very well, you have negative 1.3863 equals to minus 0.035. Divide both sides by 0. This negative, what do you have? This negative will cancel this. Our T will be equals to 39.6084 minutes. So this is what you will get. Any question on that? Any question? So let's look at another issue, another scenario. We'll call it population model. Population model. For population model, we talk about the P, which is the population, the T, equals to KP, where K is equals to growth of the population. I'll shorten the population in this way. Then our P is the size, that is population size. Okay, let me explain in a short, very way. Remember, in Nigeria, we have a population censor. We have a commission that is handling that. So they now want to test or to forecast what will happen in the nearest future. Let's say we are 200 million as we speak. Then they want to see, let me stop sharing, we'll still continue from there. So we want to see the number of what will happen in the nearest future of the population. That, okay, for this population in 20 years, what will happen? In 30 years, what will happen? So if they are doing that, how do we now agree? What are the numbers that are responsible for this growth? So that is why you see mathematics comes in. That's why differential equation you learned over the years comes in. That's where your calculus also comes in. And also the data that we have generally comes in. So that let's look at it one after the other. So if you look at your screen, we have population size. Then we need to draw a model. We call it mathematical model. How do we get a mathematical model in this case? Based on our knowledge, we know we have, let's call this one equation 1. Then for equation 1, we need to multiply both sides by dt over p, because we want to separate them. Remember, or let me just do it one after the other so that you can appreciate that very well. Multiply both sides by dt. So you see, we said dt multiplied by dp over dt equals to kp dt. This will go with this. Then we are
Sorry, sir, we can't see what you're writing, sir.
Others, can you see what I'm writing? Can you see my screen?
I can see your screen, but we can't see what you're writing, sir. I don't know for others.
That's why I'm asking. Maybe your network. Let's hear from others. Others, please. Can you see the screen? Fumilayo, can you see the screen? Steve? Yaya, can you see the screen?
I can see the screen, sir.
Oh, okay.
I can see
The
it,
person
sir.
that complained, please adjust your network. So in this case that we have the P equals to K dP, Kp dt. Excuse me. But all the P has to come together. So we divide both sides by P again. So when you divide both sides by P, what do you have? You are left with the P over P equals to K dt. Are we together now? So we can integrate both sides. When you integrate both sides, you have the P over the P equals to integral of K dt. So I have here 1 all over P dP equals to K integral of dt. So when you integrate this one, you have ln P equals to KT plus C. Then take exponential of both sides. We take exponential of both sides. What do I have? Exponential ln P equals to exponential KT plus C. So I'll have P equals to exponential KT dot exponential C. At the end of the day, I have P equals to C exponential KT. So in this case now, we have P of T equals to C exponential KT. Now, if my T is equals to 0 at initial condition, let's say T equals to 0, what do we have? We have P of 0 to be equals to C exponential K of 0. Don't forget K of 0 is 0, which is exponential C. Exponential 0 is 1. So we have P, it turns to P naught equals P of 0. Let's say P of 0 is equals to C. Therefore, at P of T will now equals to, this implies that P of 0 equals to C, meaning P naught equals to C. That is, at initial condition is equals to constant. So we have P of T equals to P naught exponential KT. So that is our model. This is what we use as a model of the population. Now, let's look at the example. How do we use model? How does the model applicable to our day-to-day life? I'll give us a table now, then we will begin to use the table. So let's look at the example 1, or let's say 2, says the table below, shows the rabbit population on a certain community. Where T is the number of years beginning with the year 2000. Let's look at A. A says determine the relative growth rates. B, write a general equation for the population P of T. Then our C said estimate. The population in 2010. Our D, how many years will it take for the population to double? Or, so let's look at the table. How many will it take for the population to double? So let's look at this. We have the table. We have the year, which is year 2000. We have the population year. Year 2000, in year 2000, we have 1,500. Year 2001, 1,577. Year 2002, we have 1,658. Year 2003, we have 1,743. Year 2004, 1,832. Year 2005, 1,926. Don't forget, we have the general method. This is our general model. In your paper, I've seen this question before several times. So please don't joke with that. So go and study it very well. You will see it there. And now for us to solve the problem, the first question says what, please? Somebody should read the first question for us. Nobody? Are we there, please?
Yes, sir.
So what is the first question, please?
You may have to scroll up, sir, so that we can see the question very well, sir.
So you did not write, you are just watching the movie. Oh, that's interesting. So what are we guys doing in the class? If you are not writing, why are you wasting your hair time? Why are you not writing? This is not CNN news. This is not Chinese news. It is always important for you, if you are attending live section, take your pen, write. It's for your own good. I'm not reading the news. You guys are supposed to be writing. Yaya, Funmilayo, are you writing or not?
I joined late, sir, so I always write, but today I have not been writing because I came in very late. I just joined.
Okay. Yaya. Wada, are you there? Okay. Steve, are you there?
Sir, I'm recording, sir.
Oh, okay. Mr. Recorder. Okay. But why are you guys not writing?
Sir, I'm in my working place, sir.
Oh, okay. Henry. Henry,
Sir.
are you there? Go ahead.
Yes, sir, I am, sir.
So why are you not writing?
I'm not writing because I usually, after watching the video once, I will always watch it like 2 or 3 more times for better understanding. So at that point, I will get more details that I would need. So sometimes I feel no need to write since I'm going to watch the video again.
Now, I'll give you guys a tip. No matter what time you join the class, talking about the FUMI now, no matter what time, so far you are not on the transit, that you can sit down with your laptop or sit down with your phone, please write. You will have, science has made us to understand that you can retain the knowledge by writing. Please always write. If you are just watching, the one you write, there are some things I don't write on the board, I just say it. You can write it down. By the time you are watching it again or you are reading it again, you can easily grab what the man is saying at a particular time. You might be thinking you have another time to go over it again. You might not have that chance before any other events take over. It is always good to write. I'm not saying watching the video is not good, listening is not good, but when it comes to mathematics, the more you write, the more you know. Let's continue. Okay, we have, if you read the question, the A says what? We should determine the relative growth rate. Remember, I told us what is growth in this case. We need to know the growth. It's here where K, what is the definition of K? K is the growth of the population. Now, if K is the growth of the population, how do we discover that? Then we know the initial population in this case is what? The first one. The first population here is what? Who can tell us?
That's peanuts.
P naught is equal to what?
1,500.
So which
Equal
is
to C.
now is P naught is not 1,005 immediately. Remember, let's just write it this way: P of 0. That is at 2000, year 2000, its initial one, which is what? 1,500. And don't forget, if you are doing it pen on paper, they expect you to start with this. Right. So meaning that 1,500 is equals to P naught exponential K of 0. K of 0 means at initial stage. So meaning that I'm going to have 1,500 equals to P naught exponential 0, which is 1,500 equals to P naught. Can you see the way I derive P naught out? Because if you say P naught is 1,500, no, it's not like that immediately. You have to start from somewhere where T equals to 0. So now we have this. We can now go ahead and write P of T to be equals to 1,500 exponential KT. Then how do we now measure it? How do we measure it? For us to measure it, what is the growth now? Remember, you are from 1,500, which is your initial. For me to measure it is going to be what? Let's say the next population is 1. Year 1 after initial, which is year 2001, is equal to what? Year 2001 is equal to 1,577, right? Then I can substitute it here. I can now say it by saying 1,577 equals to 1,500 exponential kt. What is k? What is t rather? My t in this case is 1, because I'm talking about first year after the initial, which is what? K of 1. So at the end of the day, I need 1,577 equals to 1,500 exponential k. So that all we need to do is to divide both sides by 1,005. Divide both sides by 1,005. What do you have? So when you divide both sides by 1,005, you have this one. So let's see, what do we have? 1,005 divided by this, you have 1.0513 equals to exponential k. Take the length of both sides. So what do we have at the end of the day? We have our k. If you do it very well, you have k to be equal to 0.05. So for our b now, p of t will be equals to 1,500 exponential 0.05 t. So we've done A and B together. A and B says what? It says determine the growth rate, which is K. Write the model, write the general model. Remember the K, we've done the growth rate, I will done this. So this is A, and this is your B. Then for C, it says in how many years? Let's look at the C. It said estimate 2010. 2010 means when you count this from 2001, that's 2, 3, 4, 5, 6, 7, 8, 9, 10. That is, we are talking about P at P equals to 10. At T equals to 10 equals to 1,500 exponential in your main model, which is the one in B, 0.05 of 10. When you punch your calculator very well, you have P of 10 to be equals to 2473. So that is estimation they ask you to do. D, you have, they said we should double. At what point are we going to double the population? Let's look at it. He said, how many years will it take for the population to double? Remember, the population started from what? 1,005. So at what point were we going to get 2 times of 1,005? So it simply means our population in this case will take it to be what? 3,000. 3,000 equals to 1,500 exponential 0.05 t. So when you divide both sides, what do you have? So we have 3,000 divided by 1,500. You have exponential 0.05 t. So you have 2. You have 2 equals to exponential 0.05 t. When you take the length of both sides, what do we have? We have length 2 equals to length exponential 0.05 t. So our t will be equals to length 2 divided by 0.05, which is equals to in 13.86 years, approximately 14 years. It will take us 14 years to be able to double the equation, to be able to double the population size. Any question, please? Any question? Any question, guys? Okay. Silence means no question. Thank you so for coming today. And